Welcome to my video on the reciprocal rule of differentiation. This is lesson 12 in my calculus series. So first of all, let's define it. So if g of x is differentiable at x, and we want g of x does not equal to 0, since this is going to be a reciprocal, it would blow up then. So then 1 over g of x is also differentiable. So let's write that out. What we're going to do is we're going to take the derivative of the reciprocal of a function, and we're going to find out that the theorem tells us that's just the derivative of g of x divided by g of x quantity squared. Now you might notice that this is just really a special case of the quotient rule we just saw in the last video, in the case where the numerator is just equal to 1. So if you go back and look at that other video, you'll see that if you put in n of x equal to 1, that you're going to end up with this relationship right here. Let's do an example. We'll let g of x be equal to x squared. So 1 over x squared, take the derivative of that from our theorem here. So we're going to get minus g of x prime. So that's going to be 2x, because the derivative to the power rule of x squared is 2x, and we get the minus in front of it, over x squared quantity squared. So that's minus 2x over x to the fourth. That's minus 3 over x to the third, because the x's cancel out. So one of those are going to cancel out. So there's going to be our answer for that. Now let's do another example. So let's let g of x this time be equal to x cubed. So using our reciprocal rule here, the derivative of that, we take the derivative of dx squared, x cubed, and that's just going to be 3x squared. We have to have a minus sign now because it's the theorem tells us got a minus 3x squared in the numerator, and then we get x cubed squared in the denominator. So it's going to be minus 3x squared over x to the sixth minus 3 divided by x to the fourth. So that's going to be our answer for that derivative. Now, we may notice something here, that essentially this is just kind of the extension of our power rule for negative n. We saw that in a previous video. We're taking the derivative of basically polynomials. Power rule for n less than 0 for negative n. So what we can say is, if we take the function p of x just equal to x to the n, where n is less than 0, the derivative of x, or p of x, is nx to the n minus 1. And we just saw that in those two previous examples. So let's just do another example just to verify this. 1 over x to the fourth. Now take the derivative of that per this rule right here, or the reciprocal rule. So it's just going to be n. And n is minus 4 here. So that's going to be minus 4x to the 4 minus 1, minus 4 minus 1, minus 4x to the minus fifth. So you can see there is the extension of the power rule. So let's do another example. In this case, we want to find the derivative of f of x, where f of x is going to be equal to 5 over x squared minus 6 over x, and we want to evaluate it at x equal to 1, just to see what it's equal to. So in this case, the derivative, just using our definition of the reciprocal rule, so it's 5 times the derivative of this first quantity. We just took the 5 out, 1 over x squared. Now we've got plus times minus 6 times the derivative of 1 over x. I just factored out the minus 6 and took out the derivative of 1 over x. So in this case, our g1 of x is just going to be x squared, and our g2 of x is just going to be equal to x. So using just the reciprocal rule now to do this. So f prime of x, taking out our 5, take the derivative per the reciprocal rule, so that's minus g1 of x divided by g1 of x quantity squared. And that is going to be minus 6. We'll take out our minus 6 out front. And that's going to be minus g2 of x divided by the quantity g2x quantity squared. So the derivative of g1 was 2x. So we got 5 times minus 2x, because that's the derivative of x squared, divided by x squared quantity squared, minus 6 times, now the derivative of x is x, so it's minus 1 divided by x squared, or x quantity squared. So let's see what we get. We're taking the minus 2 out front, so that's a minus 10. And then the x's go away. We're getting rid of that x and one of those x's there. So that's just going to be over x cubed. Now the minuses and the minuses cancel out. So that's going to be a plus 6 over x squared. So that's going to be our derivative. That's f prime. Now we want to evaluate at x equal to 1. So f prime of x equal to 1, evaluated at that point is minus 10 over 1 cubed plus 6 over 1 squared. That's minus 10 plus 6, because the 1 to the 2 and 3 power is just 1. So that's going to be minus 4. So there is the value of the derivative evaluated at x equal to 1. Well, I hope you got something out of this video and learned a little about the reciprocal rule of differentiation in calculus. If you did, give me a like, thumbs up, subscribe, and also leave me a comment. I always like to hear from you and see what you're thinking and getting out of this. Thank you.